Right, moments. So, a moment is something that makes something turn. Okay, so the equation is moment equals force times distance. Now that means perpendicular distance. So I'll show you what that means in a minute. So force is measured in newtons, and distance is measured in meters. So that means it's in newton meters because you're timesing the m by the m, the newtons by the meters. Now the definition of moment is turning effect of a force, which basically means a force that makes something turn. So the simplest example is a lever, like a seesaw. Okay, you put a force on one side, okay, and it's going to turn clockwise. So we say this has got a clockwise moment. Okay, and we can work out that moment if we know the force, let's say it's 6 newtons, and the distance from the pivot, which is this point here. This is called the pivot. This is called the force. Sometimes they call it the effort. And the load is the thing that we're trying to lift. So the load might be a box on the end, and that's producing a force trying to make it go anti-clockwise. So we call that the anti-clockwise moment. And then this we call the load. Okay, and that's pretty much all there is to it. If our lever is balanced, which it looks like it is there, okay, that means the moment on each side must be the same. So if that's 6 newtons and that's 10 meters, then 6 times 10 means the clockwise moment is 60 newton meters. So that's the clockwise moment, 60 newton meters. If it's balanced, this must also be 60 newton meters going anti-clockwise. That means if the load is 10 newtons, okay, then we need to do 60 divided by 10, which means the distance must be 6 meters. So we've got 10 times 6, which makes 60, and 10 times 6, which makes 60. Okay, let's have a look at what perpendicular distance means. So the best example of this is a crank on a bike. Okay, so if we draw a crank on a bike, which is the thing that turns, and the pedal goes here, so if that's the pedal there, okay, our distance is the perpendicular distance from the pivot. So the pivot is where it turns from, which is just there. Now a straight line drawn through our pivot and through our pedal, which is where our force is going to go, okay, is called the line of action. Okay, it's called the line of action. Now the force actually has to be drawn perpendicular to the line of action. So this is not quite right. So our line of action goes through where our force touches and where through the pivot is. And our force always has to be 90 degrees or perpendicular to that line of action, which goes from the pivot through to where the force is touching there. Okay? That's why we say it's perpendicular distance. You can see on this example below, the forces are all perpendicular to the distance. So we can see we've got the distance is going off like that from the pivot, and then we've got our force going 90 degrees to our distance, and our force going 90 degrees to our distance there. So it says, calculate the moment caused by the load in the position shown in the diagram. Show clearly how you work out your answer. So that's the load. We know that moment equals force times distance. So that means we have to do the force, which is 6,000, because that's the load, that's the force of the load, and then we've got the distance, which is 6.4. Okay, and if we do 6,000 times 6.4, 6,000 times by 6.4, that gives us 38,400 Newton meters. Now it says, calculate the pulling force that is needed in the steel cable to keep the jib horizontal. So the jib is this bit, this long bit here. And the reason why it's attached is if there wasn't that steel cable there, the load would just pull the crane, bend it and break it. So this holds it up straight and it pulls, it's a pulling force downwards. They would call it tension force. Okay, so that would be the tension force because it's something being pulled. Anything that's being pulled is under tension. So we know that this is balanced. So that means that load is trying to turn it clockwise, and it's got a clockwise moment of 38,400 Newton meters, because we worked it out there. That means because it's balanced, there needs to be an anti-clockwise moment of 38,400 Newton meters. So we know that the moment equals 38,400 Newton meters. We know the distance on this side is 2.4 meters from the pivot. So if we know the distance is 2.4 and we know the moment, we can work out what the force is going to be. Force is moment divided by distance. So we can say F equals moment divided by distance, which is 38,400 divided by 2.4. Okay, so if we do 38,400 divided by 2.4, that gives us 16,000. So the force is 16,000 newtons. Easy. Right, let's have a look at this one. So this isn't a calculation, this is just looking at describing what's happening in words. Okay, so it says figure 1 shows the back of a lorry. The lorry is used to carry horses. So what you can see is the hinge is the pivot. So this is the pivot point. Okay, so we can mark the pivot point here, and then the force is coming down from here. So the perpendicular distance is that distance there. Okay, and it's being pulled down. The ramp is lowered by pulling on the rope or by pulling on the handle. Okay, the hinge acts as a pivot. Explain which is easier to lower the ramp, by pulling on the rope rather than pulling on the handle. So we can see the handle is there. So hopefully you can see the handle is a shorter distance from the pivot. So because we can say moment equals force times distance. Okay, that will probably get you a mark. So moment equals force times distance. If force is equal, the distance of the handle is less than the distance of the rope from the pivot. Okay, so if the force is equal, so if he pulls with the same force, the handle is the distance of the handle is less than the distance of the rope from the pivot. So this means there is a greater moment applied by the rope for the same force applied. Okay, so it's as simple as that. Okay, it's as simple as that. You've got the same force coming from there. You'll assume that the person pulling the rope applies the same force to the rope as they do to the handle, but because the handle is closer to the pivot or the hinge, there will be less of a moment. Okay, so it will be harder to open it. Okay, with the rope, it's further from the hinge, so that means it's got a greater distance, so that means the moment will be bigger, so it'll be easier to open.